Hi everyone. Today we're diving into one of the most intriguing and often misunderstood ideas in physics, the Heisenberg Uncertainty Principle. This theory not only transformed how we understand the quantum world, but it also challenged our classical ideas of certainty and predictability. So, what exactly is the Heisenberg Uncertainty Principle? If it seems too abstract or difficult, don't worry. Today, we'll peel back the layers, using simple examples to help make this complex concept clearer. Let's start with the basics. The Heisenberg Uncertainty Principle says that, at a quantum level, the more precisely we measure a particle's position, the less precisely we can know its momentum, and vice versa. Essentially, we can't know both a particle's exact position and its exact speed at the same time. To better understand this, imagine you're trying to take a picture of a fast-moving bird. If you use a very fast shutter speed, you'll get a clear, frozen shot of the bird's position in the sky. But the faster the shutter, the less you can capture the motion. The bird's speed becomes a blur. Now, if you slow down the shutter to capture its movement, you'll get a sense of how fast it's flying, but the bird itself will become blurred. This is similar to what happens at the quantum level. You can either capture the motion, momentum, or the position, but not both perfectly at the same time. Let's briefly touch on the math. The principle is expressed through the equation delta x times delta p is greater than or equal to h divided by 4 pi, where delta x is the uncertainty in position, delta p is the uncertainty in momentum, and h is Planck's constant. What this equation tells us is that as we decrease the uncertainty in one variable, the uncertainty in the other increases. In simple terms, the more we know about one aspect, the less we can know about the other. We can apply this concept outside of physics too. Think about balancing work and life. The more time you dedicate to your career, the less time you have for your personal life, and vice versa. This kind of trade-off, where improving one thing comes at the cost of another, mirrors the uncertainty principle. It's about managing what we can know or control. Now, how does this principle play out in the real world? One of the most direct impacts of the uncertainty principle is in how we understand atoms. Electrons don't orbit the nucleus in neat, fixed paths as we once thought. Instead, they exist in a cloud of probability. We can't point to an exact location of an electron, but we can predict where it is most likely to be. This probabilistic view is a direct consequence of the uncertainty principle. Imagine trying to track a balloon in the wind. You might know the general direction it's headed, but pinpointing its exact location at every moment is nearly impossible. The electron behaves similarly in an atom. We can predict its general behavior, but we can't precisely track both its speed and position. The Heisenberg Uncertainty Principle doesn't just impact physics, it also has deep philosophical implications. In classical physics, we believed that with enough data, we could predict everything. But the uncertainty principle shows us that the universe has fundamental limits. This isn't about the limitations of our technology or measurement tools. It's a limit imposed by the nature of reality itself. It forces us to embrace uncertainty as an inherent part of the world we live in. So, in summary, the Heisenberg Uncertainty Principle challenges our need for precision and certainty. It's a reminder that in the quantum world, and perhaps in life, some things are inherently uncertain, but that's part of the beauty of exploration. There's always something left to discover. I hope this breakdown has helped you understand the principle a bit better. Thanks for watching, and see you next time.